Technologies today is storming across the globe in terms of the advancement, providing endless promising possibilities to support people's lives. Be it texting someone, making a video call, or taking picture. Imagine your phone could do something more, something that bridges us between the digitalized domain and the real world space.
Augmented reality is a technology that superimposes both the domains of human real-world interaction and computer real-world interactions, eliminating the need for switching focus between the two domains. At the same time, it also brings imagination to reality. To put into simple terms, a mixture of indirect and direct view of real-world environment simply through the display of our phone lens.
A consequence of the rapid growth in computational power, ubiquity of consumer mobile devices, along with the huge constraint imposed by the increasing number of students on the availability and the storage capacity of the lab equipments, has led to the increasing growth of interest in using AR in education. We have collaborated with a number of stakeholders, including the mechanical engineering faculty, to develop a number of augmented reality applications to evaluate the efficacy of AR in enhancing the learning experience of the student.
In this video, we will first present on the significant contribution of our project, followed by the design implementations such as how does augmentation works with Vuforia and content creation with Unity 3D. After that, we will also present the projects that we have completed throughout the year, which are geometric dimensioning and tolerancing, GD&T, colorimetric titration, and oxygen generation with bleach and hydrogen peroxide. Lastly, we will conclude the presentation with a conclusion and the future works. As for the contribution of this project, we have developed prototype of AR application for engineering education in collaboration with number of stakeholders. At the same time, we have evaluated the efficacy of AI in teaching and set the groundwork for further development in the future. In addition to that, we have also submitted and published journal papers based on the AR applications that we have developed.
Augmentation with Vuforia. Vuforia is a software development kit that enables the creation of AR application. It uses computer vision technology to track and recognize planar images, 3D objects, text writings, and other more. In the case of the project, a 2D base marker and a 3D object target is used. For a 2D image target tracking in Vuforia, the image would just have to be uploaded into the Vuforia developer portal, where the subsequent feature points on the marker will be extracted and then exported to the library for the tracking mechanism. As for the 3D object target tracking, the object needs to be placed onto the specific target marker, where the feature points of the object can be extracted with the Vuforia object scanner that is installed onto the mobile device. Objects should be scanned under moderately bright and diffuse lighting. To the extent possible, the surface of the object should be evenly lit and not contain shadows caused by other objects or people.
As for the content creation of the AR application, we mainly use Unity 3D and Blender that was freely available in the market. Unity 3D is a cross-platform game engine that provides the functions and tools to create, edit, and integrate information onto the target markers in the scene. With Unity 3D, we can overlay different elements such as objects, videos, and text. Fundamentally, Unity is used to assign the properties to the augmented object along with the user interface to create the interaction between the user and the virtual objects. On the other hand, Blender is a 3D renderer which was used to render a more complex models, and it also provides the features such as animation, compositing, and texturing of objects. Moving on to the first part of the project, GD&T, the requirement were to develop an augmented reality application where an augmented part can then be interfaced virtually with the physical base. The interface assembly can then be analyzed through better visualization. The developed application should also include UI functions for user interaction. Applications should also be designed around the learning outcomes in order to enhance the learning experience of the students on the GD&T context. As for the design implementation of GD&T, the application would involve two separate parts to be interfaced together, which are the augmented clamp to be generated and the 3D printed base to be interfaced with. There will be three user input tolerance settings that can be selected by the students: the connection hole radius, pivot hole radius, and the distance length between both of them. Mechanical drawings of the parts is provided to the students for reference. Students are expected to have better understanding on what is tolerance after using the application. They are also required to analyze the effects of tolerance on the end functional operation of the assembly, all through better visualization and learning with AR. Moving on, we will be discussing on the overall implementation of GD&T, which can be summarized into the following flowchart. The overall implementation of GD&T can be separated into three individual stages, having the stage 1 to be students analyzing the assembly drawings of the 3D printed base and the augmented clamp to be generated. In the next stage, the students are required to read and understand the instructions provided in the tutorial, and then input the tolerance settings accordingly onto the three different dimensions. The augmented clamp then can be generated and then dragged towards the 3D base to be interfaced. On the subsequent stage of stage 3, the students are required to read and understand the instructions on how to interact and manipulate the augmented clamp. Students are then required to examine the clamping tool through observation with the help of the UI functions to check whether the end operational function of the assembly has been met. Feedback in terms of the message or vibration of devices will be output to the students in correspondence to the input tolerance settings they have set previously. Students are then able to redo the exercise with a different set of tolerance settings and then further analyze how other different set of tolerance could affect the end operational function of a product.
As for the colorimetric experiment, it involves a chemical reaction between acid and base to form salt and water. The setup for the experiment is shown on the screen. A burette is filled with basic solution, meanwhile the beaker is filled with acidic solution and a few drops of universal indicator. The function of a universal indicator is to determine the pH value of the mixture by observing its color. The universal indicator color chart is shown on the screen, which shows the color of the indicator at various pH from 1 to 14. At first, the mixture should appear straight color. Upon adding in the basic solution into the mixture, the pH of the mixture will increase, leading to the change in color of the universal indicator. Then, the experimenter is required to record down the amount of basic solution added to neutralize the acid. In the following session, I will be explaining the requirement for this colorimetric titration application. Firstly, the application must be able to augment the liquid in the beaker and the burette based on the image marker. Next, a simple user interface is required to allow the user to add the base solution into the mixture. The results such as the amount of basic solution added into the mixture and the color change of the mixture should be able to show to the user. In addition to that, it also has to visually show the interaction between the two imposed liquid body. When the application first started, it will prompt out the data of chemical substance involved. Additional features like selection of different concentration, adding the base by flow, changes of the mixture color, and even adding by droplets are integrated into the application. To simulate the actual environment of conducting the experiment, when the beaker is not directly placed under the burette, there will be a chemical spillage. Thereafter, user will not be able to continue adding the chemical. As the prototype for colorimetric experiment was completed in the end of semester 1, we have decided to continue developing another chemical experiment AR application, which is the oxygen generation by chemical reaction between hydrogen peroxide and bleach. In this experiment, the setup arrangement is shown on the screen. The motivation for choosing this topic is because it can help to simulate a controlled environment for the students to experience conducting the experiment involving hazardous chemical substance such as bleach. The student is required to add hydrogen peroxide to the bleach and then measure the amount of oxygen gas produced. However, when one of those reactants is used up, it will become the limiting factor that stops the generation of oxygen gas.
You can also, because it'll help them see, like, kind of analyze, saying, alright, since it neutralized here, we went over here,
Yeah.
you should bring it a bit higher so that, you know, like them thinking like, alright, so if neutralized here, then.
Based on the feedback from the survey we collected, there are a majority of students think that AR can help them to improve their learning experience.
As for the future work in terms of the project, more interactive tools can be incorporated into the augmented reality application to heighten the learning experience of the student. This will conclude our video presentation as well as our final year project. We would like to hereby once again thank our supervisor for giving us this opportunity to work on the project. There will be Jonathan, Tak, Andy and Veronica. Once again, thank you.
Thank you.